Hi, my name is Mason. I'm part of the wind energy group for Aquaponics, and I'm going to show you what we have set up this quarter. So for our system, we have three main components. One is the power generation, two is the control system, and lastly is the aquaponics system. We'll go through each one individually and explain them more in detail. The first main component of our system is the power generation. So whether you're using a wind turbine such as this one, a solar panel, or a underwater turbine, you need to get your renewable energy somehow. In our case, we're using a wind turbine. Our wind turbine produces alternating current, which is better for traveling longer distances without loss. And once you switch over to DC current, you want to do that as close to your the battery and the other system, which we'll get into later, as possible. So you reduce the amount of losses. So we have our turbine here, wind spins, there's a generator in the turbine that generates electricity. The output is AC current. We run the current through a rectifier. What the rectifier does is it converts the AC current into DC current, and also prevents backflow, so that if there's no wind blowing, there's no power generation, we don't have any losses going back traveling up the system. And we'll cover more what happens after this point very shortly. And now we will show you our turbine and how it powers our pump. So here's our wind turbine. This is an Aleco vertical axis turbine, produces AC current. We have the output running through a rectifier. This rectifier can handle up to 50 volts, which is more than enough for what this turbine produces and our needs. We have the rectifier just to demonstrate how the system works, going straight to our air pump, which we'll show you later how the aquaponics system works. But I just want to show you, if I spin this, power will be generated, it'll power the pump, and now we have a working system. Keep in mind that this generator, the nominal operating speed is supposed to be 22 miles an hour according to the manufacturer setting. So I have to spin it really hard to get a decent amount of current to power a pump. So as the turbine spins, it turns the generator, which produces electricity, powers our pump, and we have water flow. And this is a fundamental concept, but we need to control the output of the electricity from the turbine, since there will be great fluctuations. And to do that, we'll show you in our control system how we regulate the charge of the system and the output into our motor. Our third main component is the control system. We have a lot of fluctuating energy being generated due to whether you're using solar panels and you have clouds passing by, or gusts of wind and then stale wind, or in another case, if you're using a underwater turbine, the energy source fluctuates. And to buffer this fluctuation in power generation, we use a battery to store the energy when we are getting more than enough energy, and then to make a constant release and operate our air pump when there is no power generation from our power generator. We are using a Arduino Uno for our microcontroller, and what we're using for that is to measure the voltage, which we also use to activate two relays to protect three components of our system. So the Arduino Uno measures the voltage across the battery. The battery that we're using is a 4-volt nominal battery. It has a operating range in which we don't want to try to charge the battery beyond, because we can damage the battery, and we also want to let the battery get below a certain level. And those are the two fail-safes. That's why we want to put some fail-safes in for this. And so the Uno will measure the voltage. If the voltage is high and the battery is full, then what we do is we move the relay to the next position, relay 1. Now the voltage to the battery is cut off. However, the pump is still able to operate. And what happens is the turbine continues to spin, and in this case, it runs to the dump load. The reason it runs to the dump load is because this is our second component we need to protect. If the turbine or any type of generator, such as a turbine, is spinning and it's not going to charge something, you can damage the turbine. So we have it running to a dump load, which is just taking that energy, producing some heat, but it prevents us from damaging the wind turbine. Let's say the battery is getting low, the relay will switch back and we resume charging the battery. The second main component is, the third main component is our air pump. This is a 3-volt air pump and runs on about 450 milliamps. The main concern with this is running it at too low of a voltage. If the voltage gets too low, we're at this stall point for the motor, and we can start to damage that motor if we try to run it with too low a voltage, and it's trying to work but it can't work. So to do that, when the voltage across the battery is too low, the relay disconnects, and while that does shut off our aquaponics system, it prevents us from damaging our motor, and then at least we don't damage our control system. Here is the overview of the hardware components we're using. We have the microcontroller, our Arduino Uno, which is the brains of the operation. Here we have the voltage reader. This is an SD card reader. This wasn't on the diagram. We're using this to record the voltage of the wind turbine, so we have data to analyze from the wind turbine. Here are two relays, Relay 2 and Relay 1. Relay 1 controls the incoming voltage to the battery and switches the voltage between powering the battery, or if the voltage is too large, then it will change the connection to send all the incoming voltage from the turbine to the dump load. So as you can see, this power supply will simulate incoming voltage from the turbine. Currently we have 3.5 volts coming in. Once we get to over 5 volts, this relay 1 will switch, in which case this would send the incoming current to the dump load and disconnect the incoming current from the battery, so we do not over damage the battery. Increasing the voltage. And as you can see, once we get beyond our 5 volt threshold, relay 1 disconnects, and this way we protect our battery. Now we will go back down in voltage. Relay 1's activated, it's safe, we can charge our battery. Now we will assume that this power supply is simulating the battery, and this will be powering our DC motor. So now we will illustrate how relay 2 will shut off once the voltage drops below a certain level, so we do not damage the motor by running it at too low of a voltage. So currently the motor runs no problem at 3.2 volts. It's drawing about 280 milliamps. Let's go ahead and drop the voltage and see what happens. Once we get past about 2 volts, the relay should activate and cut off. 1.9. There we go. The third and final stage of our entire system is the actual aquaponics system, where we use power generated from the wind turbine to power the air pump. We're using airlift setup so that we're reducing the demand of electricity that we need, because to move fluid using a standard water pump, that requires a lot more energy to move the fluid versus compressing air and using the power of differences in density to our advantage. So the way it works is the power from the battery powers our air pump. This is our small 3-volt air pump. The compressed air travels up through the tube to the bottom of the tube that will eventually go into our nutrient film technique aquaponic system. So the way this works is the bubbles that are coming out of the air pump at the base of this rising shaft change the density of the water in this specific location. So all of the water on the surrounding area has a higher density than the water inside of this shaft. And that difference in density with that difference in density, the water is seeking to find its level once again within this area. And what that does is it forces the water up this tube. Then you also have momentum and the fact that the bubbles are expanding, taking up space, and then they carry water with them as they travel up the tube. So water travels up the tube. At our current setup, which we'll show you in a minute, we can get for about 30 gallons per minute. We can get, it's a 3-to-1 ratio for the height above the water to the depth below the water. Now, water travels through the top of the shaft, goes through our nutrient film technique aquaponics system, and now we have our complete system working all together using a renewable wind source. So here's all the components we have for our lifting system that will raise the water. So we have a PVC tube, we have some tubing that connects to our 3-volt air pump, and that's just sitting on a sponge to absorb some of the vibration. And here's our 4-volt battery. So once I hook this up, air pump is working. You can see it's pumping air through this tube. And what I have on this tube is a series of holes to demonstrate how the flow rate changes when we have a different ratio in the depth underneath the water to the head above the water. So if we start at the very bottom, we insert the airflow here. Then we're just going to go ahead and set this at the bottom of the water. So right now, this is about 3.5 inches of height above the top of the water line and 14.5 below the water. This gives us about 30 gallons a minute of flow. So what we'll do next is change the inlet location. So we should expect to see a reduced flow rate since we have and as you can tell, there's a lot less water coming out. This might be about half that flow rate. So the bubbles are traveling up the tube, creating a difference in pressure in the tube. The water is trying to find its level, and that is resulting in the air pump lifting water. We'll do one last one, and at this point, you can see the pump is trying to make it, but there's not enough depth below the water. You can see it's bubbling up. As soon as we lower it a little deeper, we've reached that threshold where we can actually pump the water. So this is what we're going to use theoretically in the nutrient film technique to lift the water and be our main source of water drive here for the system. And the reason we're doing this is because of the low demand on power consumption. And since Pomona is in an area where there's not a bunch of wind, generating the appropriate enough amount of electricity to run a different type of system is not likely feasible. However, with this method, we should be able to run a feasible, productive nutrient film technique aquaponics system.